All right, let's talk about something really big today. We're diving into a bold 10-year roadmap that's designed to completely transform how we handle data on the internet. The goal? To move past all the compromises we make today and build a truly universal, distributed layer for everything. So, to really wrap our heads around this, we've got to start with the core problem they're trying to solve. And it's a big one. It's this fundamental trade-off that sits at the very heart of our internet infrastructure, one we're all forced to deal with, whether we realize it or not. Right now, we're basically stuck in this endless tug of war. We're constantly balancing the raw speed you get from traditional, centralized databases against the incredible reliability of newer, decentralized tech like you see in the crypto space. Let me break it down. On one side, you've got traditional databases. They're lightning fast, right? But they're fragile. They have a single point of failure. If that goes down, you're toast. On the other side, you have decentralized tech. It's super secure, but man, it can be painfully slow because of high latency. It's a choice nobody really wants to make.
And that's exactly where the TOEI project steps in. Their mission is to shatter that trade-off completely. The whole vision is to create a high-performance distributed data layer that gives you both the speed and the reliability. You know, the best of both worlds.
Okay, so you're probably wondering, how on earth are they planning to do this? Well, the solution lies in a really clever and powerful core idea.
It's this thing called the ACN overlay network. Now, the easiest way to think about it is like a smart, logical layer that just sits on top of all the physical computer servers. Its main job is to separate what the data is from where it's physically stored. And that simple separation, it's the key to making everything else work.
And this is a huge deal, seriously, because the data is now defined by its content, not its physical location. The network can automatically shuffle things around. It can create copies and split up data on the fly, all without a human having to go in and manually reconfigure a single server.
Now, you don't tackle something this massive without a solid plan, right? So let's walk through their roadmap. It's all broken down into a carefully planned 3-phase journey over 10 years.
The whole thing is broken down into 3 main acts. First, you've got the foundation years. Then, you move into the reliability phase, which is all about performance. And finally, you get to integration, where it all comes together.
So, for the first 3 years, it's all about building that solid foundation. This means creating a system for what's called dynamic partitioning, which lets the network scale out pretty much infinitely. It also means building new ways to route data based on its content and creating secure gateway connectors to manage all the physical machines.
And these gateways, they're really the secret sauce here. They're not just dumb pipes. They act like decentralized load balancers, intelligently spreading out the traffic. And on top of that, they serve as a security shield, protecting the actual hardware from being directly attacked. Pretty smart.
All right, so once that foundation is rock solid, we move into phase 2. And this is all about making the network not just big, but also super tough and fast. Fast enough for the apps we use every day. One of the coolest features here is something called automated failover. The system is basically designed to heal itself. If a piece of the network goes down, the client software spots it instantly. And, without anyone lifting a finger, it automatically reroutes all the traffic to a backup copy.
So when one of these nodes fails, the system just seamlessly switches over to another one. And the end result for you, the user? It's pretty simple. 0 downtime. The system just works.
Okay, but what about the speed? We can't have a slow network. Well, to get those Web 2.0 speeds, the system uses distributed gateway clouds. By processing data at the edge, meaning physically closer to you, it slashes that lag time you often get with decentralized systems.
And all of this builds up to the final phase, which honestly might be the most ambitious part of the whole plan: integration. This is where the network stops being just a standalone system and becomes a universal bridge, connecting all the old tech to the new decentralized web.
And this is where it gets really mind-blowing for existing businesses. Think about all those old databases out there. They don't have to be rebuilt from scratch. Instead, they can just plug into the TOEI network and instantly get all the goodies: decentralized uptime, top-notch security, and global distribution.
And what do you get at the end of all this? A self-healing global mesh. We're talking about a fully autonomous network where computers can join or leave at any time, and it has 0 impact on the network's performance or data availability. It literally manages itself.
So when you step back and look at all these pieces together, you start to realize the ultimate vision here is so much bigger than just making a better database.
See, this isn't just about building a faster gateway or a new kind of database. The real goal here is to build the fundamental data layer for the entire future of the web. It's about creating that super-fast, universally compatible bridge that connects everything, and fixing one of the internet's oldest problems along the way.
So, by tackling this age-old problem, that trade-off between speed and reliability, this 10-year plan does more than just offer up some new tech. It really makes you wonder, could this be the blueprint for the very foundation of the next internet? It's a fascinating vision, and it'll be amazing to watch it unfold.